4,500 million years ago, in what geologists call deep time, the Earth began to form from a ring of gas and dust around a small star. Tiny grains collided, forming ever larger fragments. The largest attracted more particles via gravity. As they grew, the heat generated from the collisions caused the largest to melt. Bombarded by meteors, with a surface temperature close to that of the Sun, the Earth was born. Gradually, the surface cooled and solidified. The cooling rocks emitted carbon dioxide and water vapor. Scientists now think that most of Earth's water may have come from meteors. But however it came, the water began to evaporate, shrouding the planet in a dense cloud. And then it rained for millions of years. The greatest deluge in the history of the Earth cooled the crust and formed oceans over 90% of the planet. Small volcanic islands were the only land in a green, iron-rich ocean. The carbon dioxide atmosphere made the skies red. Then, 1 billion years after it was first formed, volcanic activity split the crust beneath the oceans. Water rushed into the faults and reacted with the molten basalt to form a new rock, light, strong granite. Over the next billion years, granite would form the new continental land masses. At the same time, the first life, single-celled organisms, would begin to evolve. These organisms began to convert sunlight into oxygen. The oxygen dissolved in the oceans, rusting out the iron and turning the oceans blue and clearing the atmosphere. The minerals of Broken Hill began to form in a rift in a continental landmass 2 billion years ago. Volcanic sediments of silica and other elements were deposited, forming the beginnings of the rocky shell, or gossan, that would contain the minerals. The initial deposits of sediments and volcanic fluids reacted chemically with the hot seawater to form new compounds.
1,685 million years ago, these rocks were put down as layers in the floor of that rift. Chemical sediments, now garnet-rich rocks with a lot of manganese in them, coming out as this black manganese oxide. Muds and sands were deposited. Layers of silica and sulfide were deposited, which is our ore body. More muds and sands, and more sulfides. And these were deposited horizontally in our rift. And then over the next 50 million years, more layers of sediment up to 10 kilometres thick were deposited on top. At the base of that pile of 10 kilometres, the rocks got pretty hot. And then sometime after, another 30 or so million years after, at 1,600 million years ago, that whole pile of rocks, that 10-kilometre pile of rocks, was squeezed into a huge mountain belt. And these fabrics that you see here in the rocks were developed. Faults, folds, highly strained contacts, and temperatures of about 600, 650 degrees centigrade.
The rock cooled slowly. A lot of fluids were trapped in the ore body, and these flowed through faults in the rock and formed new mineral crystals in the gaps. A lot of the rare silver minerals found at Broken Hill were formed at this time.
So that deformation happened at about 1,600 million years ago. And it was quite intense, and I can illustrate that probably best with a piece of paper. The rocks started out as horizontally, and then they folded. And then they became maybe recumbent, and they folded again. And then they folded again, and we finish up with this this coat hanger shape of the ore body with the original Broken Hill here in the middle of town, the north part of the ore body plunging quite steeply to about 1,600 metres, and the southern part plunging a little bit more gently, and that's where the current mining is now. There are two important consequences of all this activity 1,600 million years ago. It made the sulphide ore coarser grained and therefore easier to extract, and it thickened up the ore body, making it much more economical to mine. 500 million years ago, there was a second deformation. Coarse fractures went through the rocks, and at depth cavities formed, and minerals were able to grow in those cavities.
Minerals like the calcites and gypsums formed in this way, and at about the same time, partial melting of sections of the ore body formed pegmatites. All through this time, the continental land masses were forming into supercontinents and breaking apart again due to the same forces that shaped the ore body. The continents float on the molten mantle of the Earth, and they move on the surface, colliding and reforming. Pangaea broke apart and formed Gondwana, which eventually broke apart to form the continents we know today. This movement, along with a number of climate changes, meant that the landscape near the ore body went from glacial to temperate through to subtropical jungle a number of times over hundreds of millions of years. The dinosaurs came and went, becoming extinct 65 million years ago. Although the ore body remained deep underground for much of this time, eventually it began to move to the surface.
30 million years ago, the sulphide ore body, looking much like this, would have arrived at the surface. And then very rapidly, the rain and the atmosphere would have weathered and oxidised that ore body to what sort of outcrop that we see here. Oxidised rock, manganese oxide, encrusted black outcrops like this. The transformation of that sulphide ore body in the top 100 metres is nothing short of amazing. It created a spectacular array of new minerals with one thing in common: oxygen in their formula, sulphates, carbonates and oxides that formed in cracks where the rain had percolated down and the sulphuric acid was derived from the sulphides and allowed these minerals to slowly grow and crystallise.
5 million years ago, much of Australia was under glaciers, and although the ice didn't come as far as Broken Hill, the freezing salt sprays from the ocean did, adding chlorine, bromine and iodine to the minerals still forming in the upper ore body. The first species to use rocks as tools, Homo habilis, our earliest Stone Age ancestor, appeared only 2.5 million years ago. Homo sapiens, modern man, appeared only 200,000 years ago. The first mining seems to have taken place 40,000 years ago, the Bronze and Iron Ages just a few thousand years ago. And in 1883, a boundary rider named Charles Rasp spotted some rocks on a broken-looking hill on Mount Gips Station that he thought might indicate there was tin underground.
These sort of rocks would have existed on the original Broken Hill as Rasp found it. And they couldn't have believed their luck when they started sinking on that hill. In the first 100 metres encountered incredible wealth, native silver chloride, for example, that made a fortune for BHP in the very early years of mining.
The ore body at Broken Hill became known as the Line of Lode and was one of the largest and most concentrated silver, lead and zinc ore bodies in the world. As well as fantastic wealth, the Line of Lode produced a number of unique minerals and many exceptional mineral specimens.
These minerals only ever existed in the top 100 metres below the surface. And now that's essentially gone. And the only place you'll see these wonderful minerals is here in the Mining Museum in Broken Hill.